This technical grower talk is about Berger's dedication to the environment. As a family business, Berger goes above and beyond to reduce its footprint for future generations and is committed to being an environmental leader in the industry. Environmental considerations are integrated into all its actions, from peat bog management to factory production and shipping. So Berger takes a lot of actions towards this goal, whether it be through certification, scientific projects and partnerships with university, responsible harvest, restoration and rehabilitation of harvested bogs, and sphagnum farming, and many more. Berger is Veriflora certified. Now, Veriflora is basically a certification that is given to peat producers for responsibly managing their peatlands. It's really the gold standard in horticulture industry and looks at the responsible management of the peatlands, but also the protection and conservation of the ecosystems, the conservation of resources and energy efficiency, integrated waste management, equitable work conditions, benefits to the community, and the quality of the products. Berger also adheres to responsible practices recommended by the APTHQ, which is the Quebec Horticultural Peat Moss Producers Association, and the CSPMA, which is the Canadian Sphagnum Peat Moss Association. Now, Berger is always the first to volunteer for scientific projects, and it's really a pioneer in university industry research partnerships. So what we do at Berger is we research to develop new restoration techniques that are currently ongoing at Berger sites in partnership with several universities in Canada and Europe, notably the Laval University in Quebec, and is also associated with the PERG, P-E-R-G, the Peatland Ecology Research Group. So we have biologists and engineers that work at Berger that help facilitate the implementation of these scientific projects and assist in any way we can. It all has to do with teamwork, really. So while we compete on the market, peat companies in general are members of the CSPMA and become partners when it comes to environmental considerations. Berger collaborates with other companies to support scientific projects. Restoration improvements that are made on Berger's peat bogs in context of these projects are shared to ensure that others can utilize these techniques which benefit the environment. So before Berger actually starts to open a new harvesting site, experts are sent to do a wild animal, a fauna, and plant flora survey, so a fauna and flora survey. Important water bodies are protected with a buffer zone of undisturbed vegetation. Bogs within the living area of endangered animal species are left untouched. For instance, the osprey, for the osprey, which we'll see in this picture, we leave a buffer zone of 100 meters if we find a nest of this species in our bogs. Endangered plants are transplanted outside the harvesting zone. For instance, we have the white beak sedge, we have the green fringed bog orchid, and the great sundew. Berger has strategically opened several factories so peat does not have to be transported over long distances to be packaged. Reduced transportation lowers the greenhouse gas emissions and also preserves the quality of the peat. In 2016, a new factory will also be constructed in Rivière-Pentecôte, Quebec, to further reduce this impact. Now, once we're done harvesting a peat bog, the next step is really restoration, and the goal is to bring back the bog back to its natural state as a sphagnum peat bog or a wetland and a carbon sink. So if we look at what a virgin bog looks like and an operational bog, well, our goal is really to bring it back to its natural state. To improve and expedite restoration, a layer of peat will be left undisturbed in a certain area of the bog. So if we go through the steps of the restoration process, well, what we want to do is we want to inoculate the field with sphagnum. So what we'll do is we'll actually synchronize the opening of new sites with the closing or restoration of older sites. So the living layer of sphagnum from the new site is actually removed and then shipped over to the site to be restored, and then it is inoculated. So we have an image here of actually our machinery removing the living portion of sphagnum and then transporting it to the field to be restored. We also cover the living sphagnum that we've transplanted with straw to help preserve the soil moisture and protect the fragile sphagnum fragments. The other goal of the straw is also to provide some nutrients for the plants, as nutrients are sparse in raw peat. So here we see the operation of actually spreading the straw on top of the live sphagnum. And here we actually see sphagnum starting to grow in the field, in a restored field. The final step is actually to fill the ditches. So this allows the water table to rise to its initial level. As the bog's natural shape is restored, when it is flattened, water runoff can follow its natural course. There are also other sources for inoculation. There are other sources of the sphagnum we can use to actually inoculate fields for restoration, because it can sometimes be difficult to find living sphagnum for inoculation. For instance, if too many sites are closed at the same time, or if sites are too far away, if the sphagnum type available is not well suited for the site. So what we do in certain instances is actually create a donor site. So when a new site is open, a zone is actually designed as the donor site, and this zone won't be harvested and will be used as the source for the inoculation for restoration. The donor site needs to be about 1/10 of the area that needs to be restored. Now, a new innovation that's been being tested at Berger at the moment is called sphagnum farming. So we've set up sphagnum farming test sites at our facilities in Saint-Modeste, and we're actually doing several different tests as to how high we should put the water table, what types of sphagnum species are better suited to this type of basically this method, which is to really produce sphagnum in a controlled environment. So as you can see, the project has been quite a success. After only 1 year, we already have sphagnum that is harvestable. So we really are at the cutting edge in the development of this technique, and this new practice will bring numerous advantages. For instance, the adequate sphagnum type could be cultivated on site while peat is harvested. This material will be readily available to inoculate restoration sites at the end of operations. The area needed would be much smaller than what we would need for a donor site. And also, the sphagnum that we are actually producing could be incorporated into growing media to improve the physical characteristics. We're still running some tests on this. Obviously, the restoration process isn't rapid. Sphagnum peat moss actually grows very slowly. So if we look at a timeline here, after more or less 3 years, we have a good sphagnum cover. After 5 years, we actually return to a carbon sink, and the biodiversity, or the fauna and the flora, actually returns to the site. But it takes around 10,000 years before it'll be ready to harvest again. So we're talking about a long time. But restoration is undertaken for environmental purposes only. It's not done for our future needs as a company. So another option that we have instead of restoration is actually rehabilitation of harvested peatlands. So some sites will be rehabilitated into other wetland types. For instance, marshes, which are ponds that will be dug into the peatland to actually provide habitats for wildlife. We have also the option of selecting tree species that will be planted into the bog to create forested wetlands. We can actually even plant blueberries or cranberries, and which can be actually harvested. Bringing the harvested sites back to a healthy wetland is a priority for Berger. Since 2015, Berger has planted more than 70,000 trees in its harvested peatlands. So environmental leadership is also in the details. All the roads that we actually build in our peat bogs are mostly made from the trees that are cut during the site opening operations and from roots collected with the peat manufacturing process. Berger was also the first in North America to use the skyscraper format, which greatly reduces plastic waste. Its its skyscraper system, still utilizes less plastic than competitor equivalents. All plastic wastes are actually sent to a recycling factory. Runoff water from our composting sites are collected and treated. Also, the heat generated from our perlite and vermiculite factories is actually reused to heat the mix factories during the winter. We actually built a system where we have tunnels that actually bring the heat from the perlite and vermiculite factory to our actual mix factory. So it's really a way, it was heat that was generated by the production of perlite and vermiculite that we were losing, and instead of using energy to heat our mix factory during the winter, we actually designed a system to bring that heat over to the mix factory. And we have many other efforts that are made to preserve our environment. So Berger cares a lot about the environment and strives to reduce its impact on fauna and flora. We are constantly looking for new areas where we can improve and implement new processes that go above and beyond standard requirements.